Good morning. Can everyone please tell me if the audio is working? I think I got my lapel mic working in macOS. So hopefully it's working and hopefully it's loud enough. If it's not, please let me know. Cheers. Muted. Little low. How's that? Is that better? I don't want to push it too high. Audio is fine. Sure, but it means I can move around and I don't want it too loud. Very, very low. Speakers at max. I don't think it's very, very low. Okay, hang on. Yeah, you can't have some people say it's good and some people it's very low. It'd be very hard for me to adjust that. How's that? Yeah, that's my printer going. That's the obnoxiously loud bamboo carbon. Could say the intro sound is too loud. Right, okay, well, yeah, that might be too loud. That's better? Okay. Let me know if it pops or anything. So I'm just letting everyone know now this is going to likely be a disaster stream, but we'll get to that in a sec. Firstly, good evening, good morning, hello everybody. So a couple of caveats for today, straight up. I've been awake since 2 o'clock in the morning. This is my second coffee, the smallest of my 2 coffees. I've got a massive sinus thing going on. I don't know what it is. My head is pounding like someone's playing drums in my head. I've taken a whole bunch of, drugs, paracetamol, Telfast, extra strength, non-drowsy. I don't know what it is, hay fever, something. So, yeah, brain is currently melting. Hopefully caffeine will help, but maybe not. So that's the first thing. The second thing is, Otis is in bad shape. Well, so I've got some parts being printed at the moment, which probably won't be finished for the stream. It's about 3.5 hours of printing, I think. I got in as early as I could this morning. Just after 5 o'clock I got in this morning. I do have some parts I've reprinted that I'll show you why, and I can disassemble and put on. Some things I've already done. I've made some progress on Otis, but not a huge amount. I got work to do. I could have just sat for days and days tinkering, but at the end of the day, I had other work to do. So I did make a little bit of progress since last week in terms of the design and implementation, which I'll show you in a moment. Did not make any further progress though on the limitless homing but I think I might have worked out in my head what's going on there. Maybe, I don't know. But I did finish the next version of the controller board, and I did end up putting connections for 8 physical limit switches in there. So that's currently being fabbed. I should have them next week, hopefully. I need to build those because that's also got my light control and my servo control, which again we'll get to in a moment. So there has been some progress, and I started playing with some camera stuff. Unfortunately, the Raspberry Pi that I was working, that I spent a long time setting up with the latest version of whatever the 64-bit OS is, and compiled OpenCV for and blah blah and everything else. For some reason, I can't boot that Pi. I can't boot the image. Doesn't matter what I put the image into, and so I don't have access to whatever my last set of code and project was that I was doing on the gantry. And so I've had to go back to an earlier version of my stuff that was on a different SD card, was on a different Pi. And I don't think it's worn out, Mike, because it wasn't used that much. I don't know. I must have done something in the OS, maybe installing something for the cameras. I was playing with the Raspberry Pi camera module 3s on it, like only 2 weeks ago. I must have done something and I just can't get it to boot. And I'm not going to worry about trying to troubleshoot that today. So I've gone back to, I've got a Pi sitting here working with an earlier version of my software on it, but it's an earlier version of my software, and some of it works, some of it doesn't. And I'm been trying to, on and off yesterday, trying to work out how to get something working to show you all. Ugh, it's been a bit annoying. Okay, yeah, cool. So, I don't know what you're trying to do there, cable tie, but that ain't going to work. I'm making homing dot on the top of the lower camera, so the upper... Because the upper camera can't see the lower camera. Well, it can't... it needs... The homing is about the limits of the machine, not about where it is in space. It's got to start... It's got to know where it can move. Anyway. So, firstly... all of that aside, I'm about to go through the list and say hi to everyone, now that a few people have joined, but I also have some mail to open, which I'm going to do first. It's pretty exciting. I got something delivered the other day, and I want to show you all what it is, but it is actually made by a community member and one of my patrons, and so, yeah. I'll show you that in a moment, but first let me go back through the list and say hello to everybody in here. So Alan, good morning, and Adam. Adam's also not feeling well. He's also tired and got a headache, so we're going to commiserate together. Antonio, hi. Johnny, hello. Johnny's got a hangover. Oh, I got to speak in a soft voice. Is that better, Johnny? Poor Johnny. Oh. Sergeant Bond, hello. Andy Calloway, hi. Robot Wars Part 2. Oh, there's no wars. Maybe. Well, it looks like it was. Chat history not working. I left a comment 12 hours ago. Yeah, you can't do that on YouTube because the stream's not live. You can't guarantee that any message you leave in the chat will be there. Yeah, they refresh that all the time. Beata, hello. Dutch Taurus, hi. Braden, Otis. The community named it Otis last week. For damn, I left a compressor on. I'll go turn that off in a moment. So optical inspection, that's what it stands for. Mad Techie, hello. Henrik, good morning. And Wagon Loads, hello. You tried my idea of rotating the top cam to the side. Yeah, I've got it. It's rotated 60 degrees. I'll get to that. Crazy Roops, hi. Rota, hello. David Dessa, good morning. Graham, hello. Michael, hi. Evolix, I think. Hope I got that right. Mr. England, hello. Mike, good morning. AJ, hello. Peter, good morning, Peter. Sorry about last night. Yeah, I had to get home. It was a long day yesterday. David, hi. Christopher Bransdale, hello. Ellen Gillespie. John Meeking, hello, John. Okay. Oh, and it jumped. Okay, going backwards now. Marius, hello, Marius. Sid, hi. X-Micron, hello. Embedded Hobbyist. Going backwards. Okay, I might have got everyone. No, Andy Day. Did I say hi to Andy before? There's a few Andys. Okay, I think I might have everyone now. Good. On the mobile phone, it's too hard to type. Just listening today. Just listening on your mobile. Cool, it's nice to have you here though, Cable Tie. Zuber, hello. I think I got that right. Cool, okay. I think that's everyone on the list. So, let's start off with some mail, although I don't know how I'm going to fit it on the camera. I might have to switch to... Let me switch to here. Now we'll get to see if the microphone and camera is all working properly. Which one do we want? That one. Okay. So, let me just move some stuff out of the way just for a moment. I've not even opened the box yet. Hopefully it'll be in focus. Okay. Box. came from Mexico. Mexico. So full disclosure, I'm not exactly sure what's in the box. I ordered and paid for 2 things in the box, but I believe that he sent extra things, and they covered the shipping cost, which is really nice of them. Woohoo! Okay, so I have, well, there are 4 things, 2 of each of the same thing. Okay, these are, I don't even know if you're going to be able to see that. This is called a QB Smart AC controller. I don't know, is that in focus? And then these are called ARIA control panels. So I'll put a link to the website so you'll know what I'm talking about. So it's an English website, but some of it is still in not in English. So this is the company, and the user on Discord is Scraffy. So the story of this, let me just go to here, is that as a project quite a while ago, I had an idea I wanted to take an ESP32 and I wanted to set up some IR for it where I could capture the controls from my air conditioning units here and be able to control them via MQTT or via Wi-Fi or whatever. So it was a project that I wanted to do at home, never got around to it. It was something I wanted to set up here when I moved in, never got around to it. It's been on my list for a really long time. And so this is something that Scraffy's already done. He's got this whole setup. If I go to QB-G4, which is what I got, he's gone and done all this work to work out all of the control systems for stacks of different air conditioners and stuff. And he's built these things that let you control your air conditioners, like mini splits and stuff. And you can do it via Wi-Fi, and you can, program to do all sorts of stuff. What is this aircon that you speak of? Is this an airplane business? What? I don't get it. And how can you not have aircon there? Yeah, it's really nicely done. And this does exactly what I want it to do. As you can see, some of it is in English, some of it's not in English. They're working on an updated website. And so I thought, stuff it. Like, I don't have time for another project right now, so I thought I would just buy 2 of these, one for each of my one for downstairs, one for upstairs, so I can program them to come on and off whenever I need to and be able to access them remotely. And here we go. Thanks, mate. So, except how do I even pronounce Articomex? No, Arteco MX for Mexico. Right. It's Scraffy. He's in the chat. Big thanks for sending the Arias as well. So I want to open these up, have a look. This camera is probably not the best way to do it. I'm not sure how I'm gonna do this. I won't spend too long on this, but I do want to have a look, and I want to do a shout out because they look on the website. They look like really beautiful professional products, and I'm sure they are. I'm not saying they're not, but I really want to see them. I want to put them in my hand. And these cubies, I think, are much. Let me just go back to. Oops, upside down. All right, let's just go back to here. They look smaller than I thought they were going to be. Okay, so these were sent without power adapters intentionally, because the adapters weren't going to be compatible for here. I've got plenty of power adapters, just needs those. So they're USB-C on this side, and then A just goes into like a normal you know, 5 volt wall wart, whatever. Black dot in the center is an IR transmitter. Yes, it's an IR transmitter. And so the idea is you put this near the air conditioning, kind of, I think, facing that particular direction. And you can access this via your phone, like via an app, to control, do whatever else you want to do. And then, but what they've also got are these, and I thought these looked fantastic. By the way, that's really nicely, it's really nicely made. Okay. So the area is a control panel that you can also control it with. So if you don't want to do it remotely, you can put a panel somewhere that you can then, basically I want to get rid of the need to use my remote controls, which is are not great. So this is a control panel with a whole bunch of, like, I'm assuming they're like capacitive touch type buttons on the front with a little display that you pair to a QB. I think you pair it to the QB, and then it doesn't have to be hung. Like, it's just a portable. It's like a portable remote control, right? That you can then control, turn things on and off, temperature up and down, all sorts of stuff. So I'm really excited to get this going. I'm hoping that my air conditioning units will be one that this has already got a program for. It should be, but apparently you can also teach them as well. So this is actually quite nice. It's got batteries inside. So I'm just having a look inside. I really want to power this up. How do I power this up? Oh, I've got to pull the thing off the batteries. Okay. There we go. Oh, look at that. Nice display area. Oh, okay, that flickers a little bit. It booted up with a nice little logo. Let me just change cameras to one that doesn't flicker. So you can see there it's got on the screen. Oh. No, not off. It's got like temperature information and stuff, little OLED on there. I'm not sure if it's color or black and white. Oh, nice little animation. Oh, cool. So temperature up, temperature down. Anyway, it's like a remote control. Walk around with it anywhere, but it's wireless. It comes with a small purple PCB key to open it. Ah, right. Yes. Okay, there it is. There's a little purple key there, right, to open the back to be able to get the batteries. So the difference between this and the remote controls I've got right now is remote controls are IR, right? And so I've got to actually be pointing them. They're not great, and the distance to control them. Like, I can't take the remote control from downstairs and have it up here and sit here and turn on the air conditioning downstairs or the heating. I have to actually walk up to the edge and kind of point it. It just can't break through whatever the wall is here. I don't know why, but the thing with these is they're Wi-Fi, so it doesn't matter where I am, it's going to be able to control it. As long as this has access to a rough direction of the unit. So I'm looking forward to installing these and playing with these and setting them up so I can program, for instance, on a cold day. Like, I could be at home and know that I'm going to come in and I want to do some pick and placing in the morning, early in the morning, and it's going to be freezing in here or it's going to be really warm or whatever. I can, at home on my phone, turn on the air conditioner or heating and get stuff ready for me on the trip in. So when I get here, it's going, rather than getting here and wasting half an hour or 45 minutes. Anyway, I just wanted to show that. We'll get on to the main stuff now, but this is really cool. Really nicely made stuff. Well done. I mean, it looked really nice on the website, but confirmed, very nicely made products. So I got two, one for each unit. Is the battery rechargeable? It looks like the battery is not rechargeable. I don't know if you could put rechargeable. No, well, the thing is, there's no charge port on here. You could put rechargeables in here. They're just normal batteries in there. I'm assuming that I can open this up and put rechargeables. Batteries AA non-rechargeable. They should last around 5 years. Wow. Okay. But assuming we could put rechargeables in here, we just can't charge from it, right? You could take them out and recharge. My mum's Wi-Fi can't get out the room the router is in. Walk out the door and the signal is lost about 4 feet from the door. Really? Is that 5 gigahertz or 2.4 gigahertz? If it's running 5, you should switch it to 2.4. This is really nice, really responsive. Okay, I gotta stop playing. Let's get on to Otis. Let's talk about Otis. Otis. 2.4 and it can't go through the wall. Really? I think you need a different router. That sounds terrible. Hey Azzy, how you doing? And hello to anyone else that's popped in that I haven't said hello to. So, yeah, it needs a better router. I will, once I've got this stuff set up, I can show you all. Oh, there's something else I should show you. My new oven's here. It got delivered on Monday, and I got it off the pallet yesterday. And although it's not in line right now, it's next to my other oven. I got it wired up and powered yesterday. Had a very quick play with it. Oh, it's very nice. Hello, Dutch Maker. Hello. So I don't remember your nickname that you told me last week. Mena Bendranath. Sorry. AC upstairs 25. Cool. Looking after dear Sion. No, not even Sion's looking after dear Sion. Pizza for lunch. Oh, it's a very nice oven. So for those that aren't aware, I got the Neoden IN12C. And so the oven looks like... Whoa. Everyone makes pizza comments. Surprise, surprise. So this is what the oven looks like. Well, it's still wrapped up there. It's off the pallet now. And it's all been unwrapped and it's all been set up. So I can give you all a closer look at that in the future. This is a chain-based one, as in a conveyor, not a mesh. So I can get this in line with the rest of the line and get the restacker on the end of it. So I can now go from start to finish, fully automated all the way through. Hello, Nassim. So yeah, that's pretty exciting. And it probably looks smaller than it is. It's about 2.6 meters long. Oh my God, it is so heavy. It's like 400 something kilograms. Anyway, okay, so that's exciting, but we'll get to that another time. So let's talk Otis. This is backwards, right? So kind of hard to, excuse me if I fumble directions and stuff. So I made a few changes. The first one, a few people suggested to me last week on the stream, and I had a chat with my mate Peter Thompson afterwards. We were discussing, again, the whole offsetting of this camera. So I did end up offsetting the top 60 degrees. So that way...
MICIOUS1 says halt and catch fire.
Ooh, I love that show. And hello... Mischius one, I butchered that name. So it's offset, 45 wasn't going to be enough, I didn't think. So it's offset 60 degrees. And so what basically means is I can have it like this to capture. It's not facing the camera. To capture, and then it can obviously move around, do what it needs to do for inspection. So that's been done. It's not the final design and layout, but it's good enough for now to experiment with. I've done some continued work on the front here. I got some new steppers. Bought some steppers from Steppers Online. Just for this access for now, I've gone with a thinner. So it's still a NEMA 17, but obviously quite a bit different in terms of size than what I had here before. Thinner and it's lighter. I don't need a lot of torque for this arm, and so ended up going for a smaller stepper. I didn't want to go any smaller than that though, and I also moved it to the top because on the bottom it was in the way of cable management. I'm currently printing a new set of arm like here and here on the 3D printer, just to give things a bit more stability. Is that called a pancake stepper? No, it's not a pancake stepper. Pancake steppers are much thinner. This is just a low profile NEMA 17. The pancake steppers aren't NEMA 17s, they're a different type. The problem with the pancake steppers is that you don't get a shaft on them. You generally get a cog or like a gear at the bottom, and it makes interfacing them quite hard to work with. Pancakes, yum. So that's been moved to the top. The new pieces I'm printing, as I said, more cable management, better support. There seems to be a bit of you can't really tell from this angle, but look, it's all made out of PLA right now, and this is only for prototyping, but the PLA is not lasting, like with weight and stuff, as I'll show you in a moment. So there is a 2 degree kind of drop on this arm in this section here. So I've put some more support in that's being printed at the moment to try to strengthen that. As you can see, I've now got, so there's actually a camera in there and the light ring. I've got a mechanism in here. This is actually on a servo, a 180 degree servo. So I can control this, although the controller board I've got here right now doesn't have the servo control. That's why I need the new controller board. Put the stepper inside. The stepper can't go inside the arm. And I don't really care having it outside right now, but there's no room inside the arm. I'd have to have make the whole arm much bigger, and there's no advantage in having it inside the arm. So yeah, like I'm not going for the nicest looking robot award right now. I'm going for something that works, like mechanically that works. Like I'm more concerned about things like all the cable management for all this type of stuff. So what I've ended up doing with the cable management, I tried a few different things, but I ended up just, if I tilt it over, maybe you'll be able to see, there's just a couple of, like, actually I'll show you in CAD, it might be easier. Top. Okay. So what I've gone for is, rather than trying to fully enclose cables, is I've just got sections like this that the cable will channel through, and I'm just actually putting M3 bolts through it, right? I don't want the cables tight. They need to be able to move. They need to be able to shift with the rotation and stuff. So the easiest thing was to, run them through a channel and then just have some bolts in there like what I've got here to support them in there so they don't fall out. And that's actually working quite well. So I've got that on both arms now, but it's only on the first arm. The second arm hasn't been reprinted yet. That's happening right now. Hello, Imla. Looks like an Arc Droid robot. What is an Arc? I don't know what Arc Droid means. Arc Droid. Is that from a show or something? So yeah, that's currently being reprinted. And I've also added a bit more. So I have bearings on, no, not that one. I have bearings here on this piece, like press fit bearings, but I didn't have them on the inside bit, and so I've now added them on the inside bit as well, so I'm reprinting that section. So this is working, and I mean I can show you some images through this, but oh, is it a CNC plasma? Okay, cool. A Ascara-based CNC plasma. I'll have to have a look at that. Now, one of the things that did go wrong, and I mentioned it the other day, like so after the stream last week, I was playing around quite a lot with trying to get the homing working for 3 or 4 hours, and I ran the stepper pretty hot, and you might be able to see it's warped. It's hanging low now. This section here is bent down. No surprise, it's PLA, right? Hey, Alan, how you doing? As I said, I spent like 3 hours running the stepper quite hot. So that's dropped a bit. And until I fabricate this out of something that's stronger than PLA, I'm going to continue to have similar type issues. But what I've done is remade this whole base section here, and I've added some vertical support to it. So it's not just one bit of 5mm thick PLA that's going to warp. This is going to have a lot more support. So I need to swap that out today. I need to pull this apart in a few moments. Not really, because they're not flat. Like, they've all got at least one side where there's extrusion and stuff. And I don't want to make 10 different pieces that have to somehow screw together and assemble. The idea is that these stuff will be machined out of something rather than 3D printed. So, and acrylic will warp as well anyway. So acrylic really won't help. They need to be cut out of something much stronger. But this will be perfectly fine for now. This will give it stacks more support than what it's got right now. So I need to pull all this apart to do that. I have not put any connectors on the end of here yet. I need to do that. So currently this step is not connected to the board. I'll need to do some JST, PH. I need to crimp those on. I'll do that shortly on the stream. Need to work out which cables are which. Looks like low poly users enterprise with support still attached. What? Looks like a... Oh, that's not for me, I don't think. Okay, cool. And so, as I said, the software, there's a bit of a problem with the software. I've had to go back quite a few versions. I'm also going to have to put some form of light on the top as well, because it's just, there's not enough light coming in. So, and the other thing is I need to, you can't really see from this angle, I need to teach it scale. Right now I've got no ability to teach it scale, and the old code that I've got, I can't use because it was using GTK and I didn't recompile OpenCV for GTK. It's frustrating. So I am currently VNC'd to the, to it, and I do have cameras kind of working. So that's the main overhead camera, right? As you can see, I need to, So what I need to do now is rewrite my scale code. So it can understand physical space. The new plate looks like a low poly USS. Oh, right, okay. Actually, it does a little bit, doesn't it? Dun, 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 dun. Okay, anyway. I probably haven't seen Star Wars. What? We're talking about Star Trek, but don't worry about it. So, this is 10 centimeters, this is 50, and this is 100. And clearly, the measurement code is for the gantry. That was the joke. Another dad joke. All these dad jokes for you, Mike, this morning. I really like Chewbacca in Star Trek. He's great. Are you going to anchor the base so it doesn't drift during going through its motions? Well, right now I don't know how, I don't know where the base is going to be sitting. So some form of anchoring, sure. What? These are millimeters. Well, that's, sorry, what did I say? So that's 10 millimeters. That's 1 centimeter. Sorry. 50 millimeters. Did I say centimeters? Sorry. And 100. So I need to get my calculations correct. And as I said, the code that I wrote to be able to do that won't run, and it needs a complete rewrite. I need to strip out all the UI stuff from it. It's a bit frustrating. So maybe we can just bodge it. I just need to get this to recognize 100 by 100. It's a big robot. Yeah. So, so if I shut that down, so it thinks it's 73 right now. I got to remember where all my code is. Right, pixels per millimeter, millimeters per pixel. Can everyone see this? Let's get rid of that. So this is from the old gantry stuff. So right now it thinks that it was the big box that it thought was 73, wasn't it? Damn it. Hang on. Try that again. Okay, detect movement. Yeah, so the big box it thinks is 73. So oh my god, how am I going to work this out? I can't remember what my formula was. Is my formula in here still? I don't remember how I did this. Huh? I don't know what you mean, wagon loads. I'm not moving the robot. This has nothing to do with moving the robot. This is just about the vision knowing what its pixels per millimeter and millimeter per pixels is. That's all. Nothing to do with movement right now. I'm just looking at my old code. I think I sized the image specifically. Oh, that's really annoying. So I know that, so 73 millimeters divided by 0.18, oops, 1882829, close enough. No, it's not what I want. 13 points. Oh my god, I told you, I warned everyone at the start that my brain is mush today. If that thing's at 73, then I just need a... Do you need to go up or down? I think I need to go up. And that's got to go down, but I don't know what. I'm just going to guess. Because I can't, my brain can't work this morning. But I really need to have it calculate the size correctly. No, other way. I went the wrong way. So times 0.73. This one's got to be divided by 0.73. And this has got to be times 0.73. Maybe? No, it needs to calculate the size of the squares. That's the problem. Why is that not picking up the bounds? No, that didn't work. So maybe it was the other way around. Times and divided by. Well, it can't find the ratio. It needs to know based on some type of fixed reference. Oh, come on. Focus. It doesn't like the hand being there. Okay, that's close. 101 millimeters, so there's a rounding issue there. I'm not sure how I'm going to solve the rounding. I need it more accurate than that. What I really need to see is what the because I'm just rounding that value, so 100.1. I need to actually show cam output. I need to see where I'm rounding it. Why is that? Show cam output. Where am I writing the text? Right, SCARA uses some kind of coordinate system where you tell it endpoints and does whatever it needs to get there. Well, that's not specific to SCARA. That's inverse kinematics. Yeah, it will be using inverse kinematics to move to particular positions, but again, we're not there. Where am I showing the coordinates? So I'm showing the image. Could be in detect panel. Detect. So this is, as I said, this is older code which has been, which I'm going to have to go through and oh, this is really old. Okay, scale width millimeters. So I want to see if I'm rounding it or not. Right, I am. I wonder if, so if I times it by 100 and then divide it by 100, I'll get more precision. Maybe. Hello, Vishnu. What's your opinion about OpenPNP machine? Can that be used for small scale production? Well, they're two different things. There's no such thing as an OpenPNP machine. One's software and one's hardware. So, like OpenPNP can run on lots of different machines. So, what machine specifically are you talking about? Okay. So we can see there that we are over, but less than. Oh. So can you be, yes, but for what machine? OpenPNP is just software. Runs on 200 different machines. The software is irrelevant, right? OpenPNP is great. but on a crap machine, it's not great. So, and 50 boards is not a lot of boards. But again, what machine? What actual P&P are you talking about? Right, so it's actually bigger. The scale is bigger. Like the 101 was clamping it. It's actually 101.62. So you're talking about making a custom machine. I wouldn't bother. Buy one, like a Lumen P&P or something else. If you're going to make your own pick and place machine, you'll never get it working for production. Well, you will. You might. I don't know what your skill set is, but one is a project and one is a machine to manufacture boards. If you want to manufacture boards, don't build your own machine. If you want a project, build your own machine, but you'll end up not manufacturing boards. So, you know, there are a lot of open P&P software-based pick and place machines that are either kits or pre-made that you can get with a 10mm by 10mm square and a bigger known one. I don't understand what you mean by known one. There is not such. These are known. I don't know what you mean. I don't know what scale is a known one for this distance. If I knew that, then I would know the number for these. There's no such thing as a known one. Like you know, that has to do with the distance from the camera, to do specifically with the focal length and the lens distortion and blah, 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 blah. If I knew all those values, I wouldn't need to train it, right? I just want to get it close just for the moment. Oh my God. How many decimal places do I need? Did that go down? Or did that go up? I don't know if that went down or up. Come on, detect movement. Okay, it's going the wrong direction. So 3.5. Come on. It's getting closer. Very close. If I get it, it'll stop jumping around if I straighten up the picture. So just to let you know, this looks a little bit laggy. It's because I'm VNCing via Wi-Fi to it to have a look at the screen. So there's the capture update of the UI and then the delay of VNC to come to here and then capture to OBS. So there's a bit of a delay there. Okay, that's really close. Not really sure I can get it much closer than that. You got to remember, I don't need, it's not a pick and place machine, right? I don't need to be placing parts at a particular precision. I need to just get roughly where things need to be. So 99.95, 99.8. Obviously, so that's a good example where the lens isn't quite symmetrical because the measurements it's getting aren't perfectly square. But it's pretty close. So if I now put this here, take my hand away. Okay, so I know this panel is 99 millimeters wide and about 153 millimeters long, or 152. It's obviously grabbing the overhang of the USB, right? So you can see there that it's a bit further away from the edge of the panel. Not really a lot I can do about that. But as you can see, lighting is going to be a big issue. Like, you know, if I put that on the desk, which is much darker, it can't recognize it. So that's a bit of a problem. I'm going to have to work out. Obviously, like the conveyors that this will be sitting on for me anyway, they're not dark, they're much lighter. And it'll be in a lighter environment than what this is in right now. I don't have all my lights on above here because it blows out the camera. So like for the moment, I'll just put a piece of paper down. But as you can see, the whole idea is that it'll, get my hand out of the way. Why is that not detecting? Okay. So the idea is it'll be able to capture this and then recognize what the board is. Now, something I was playing with in the other version of the software, I'm going to have to remember how I did it. I tried playing with OCR capture to be able to recognize the board. Right now it's, hey Wayne, will the boards be warm? Does the camera have a removable IR filter? I don't know if this one's got IR, but the inspection one does. This is just to determine that a board has come in, the top one, and to be able to recognize the board and work out where the board is in 3D space. That's it, right? Once it's done that, it switches over to the other camera, which I'll show you in a moment. So I was playing around with OCR and to be able to read what I've got on here to determine what the board is, right? But it's really slow. Just the Raspberry Pi is not super fast. It was taking about 7 or 8 seconds per frame to do an OCR pass on the image, where the same code on my Mac at the time was taking about 0.7 of a second per frame to do an OCR scan. And either way, neither scan was giving me really good results. The thing was too small. But what I could do is I could actually grab the image and crop it and then just run an OCR scan just on that. But my plan with the detection, what I got working was that it grabbed an image of the board. So there's this teach thing. So right now it can't detect the PCB because there's no reference there of this particular panel. So what I could do is I could click on teach, give it a name, save it, and so I'd save this as Tiny Pico V3 U1 for the UFL version, and then it would save that image of the board down, and then when it does a detection, it grabs the image and it goes through the database of all of the different images and goes, oh, I know what that image is. That's a Tiny Pico V3 U1. So the idea is that the detection, so that let me just cancel this. Shut down. So the process is, thanks James. So the process is a board comes through, try it again. So the process is the unit's just sitting there after it's homed, and it's just its position looking over the conveyor, and as a board comes through, right, it does a detect, see that? It detects there's movement, and so it goes into detection mode. It would tell the conveyor to stop moving. So it sits it still. It would detect what the board is, and once it's detected, right, I'll do a skip that, it then switches over, let's skip. Oh no. Why is it not identifying? That sucks. Okay, I can get past that. Again, this is really old code. I'm not even using this UI framework anymore. I'm using something, I'm using Flet now. That sucks. Anyway, and then it'll go into inspection mode. So let me see if I can get, now that I've got that rough calculation, let me see if I can go just into inspection mode. Detect panel. Or maybe I never even implemented this. It does identify. See, I don't even know if I've got it in here. This is so old. Ugh. Yeah, I don't even have it in here. Okay, that sucks. Look, this is, I was devastated when I couldn't get the SD card booting. Totally devastated. I can probably hack it though. What I'm gonna do is turn the,
Quixotic Geek says, greetings mortals.
Hello, Quixotic Geeks. Welcome. So, as you see, that light's pretty bright. I could probably hack this into using a different camera. So, I'll swap these over. Every time the Pi boots, or every time you plug something in, the order of the cameras changes, which is really frustrating. So I had to write some code, 5 o'clock this morning. I wrote some code that goes through and does a list of devices in Python, in subprocess, and then scans through and finds the entry and returns the ID of the video stream. Really annoying. Let me just switch these around. So this should now do the whole thing we're doing, but with the small camera now, hopefully. Why is that not working? Okay, it probably doesn't like that. Probably put it in a mode that it can't support. No. I think a UDIV rule or two could help. Possibly. This is running an older Raspberry Pi OS version. Can a HD webcam used for OCR? Any camera can be used for OCR. It's just really slow. The Pi's just not fast enough. Or the Python libraries that I found for OCR capture just aren't optimized enough. I don't know why it's not coming up with the camera. It should be. It's there, video 0. Hey Mitchell, no, I shouldn't have to, no. I shouldn't have to comment that out. That's just assigning. That's, doesn't really matter. Well, yeah, okay, maybe. Maybe it doesn't like the double. You could be right. There you go. Oh, blowout. So the settings for this is not the right settings for this camera. Da, da, da. So I was hoping to have sorted out a lot of this software earlier. That's really bright. What's if we turn the light off? It's also way out of focus. Oh, right. It's out of focus because... So this is an issue of the height of the robot, right? So I've already set the focus point of this. This has got to go all the way down. Okay, now we can probably... It's still going to be too bright. Way too bright, but we can fix that in a moment. So, skip detect. Yeah, too bright. But as you can see, this is it. Probably the white doesn't help. I need to do a white balance on it. Okay, hold on. Well, I can't do a barcode because I don't have barcodes on my boards. I don't have QR codes on my boards, and I don't want to require anyone else that wants to use this to also have to do that. Is there any alternative SPCs to run OCR instead of a Raspberry Pi? Not really. There's a few SBCs that are a bit faster than a Pi, but they also have shocking OS support and, you know, not necessarily good camera drivers or anything else. So let me just have a look at my code that does the setup capture cam. So, 10, brightness 64. Okay, you could probably drop the gain. And probably drop the exposure. Maybe even the brightness. Let's try that. Need a black light to compensate for the white light. There we go. Okay, that's better. I need to play around with the settings, replay with the settings, right? I mean, this is still not quite right. But anyway, the point is, so this is the global shutter camera, not a rolling shutter. So as you can see, there's no blur or any blur or anything lag you see right now is the VNC thing, right? But this is not like a rolling shutter camera, so it's always in focus, as long as I get my height right. But as you can see, there's a bit of distortion as it moves around that chip. You see the pads on one side, then you see the pads on the other side. So it's all about getting it in the right spot. But as you can see, you can move around the board. I mean, that's pretty fast, whatever, looking for parts. And, how did that change focus? You get it lower. So the reason I'm using this board is you can see that there's a look at that diode. So that diode there is going to have a problem. So, and right now the code that this is using is designed for the overhead camera. So it's cropping and it's running a resolution. Hey Liam, and hello to anyone else I haven't said hi to. It's the resolution and everything about what it's doing right now is based on the overhead camera for detection, right? It's not going through the path that does I've kind of hacked this, switched the cameras and hacked this to kind of get it to see through this camera. But as you can see, this will be a fixed height. I've got up and down, like that's just me flexing the arm, right, as I'm moving it around. It's like it wouldn't be doing that itself when it moves. But I'm going to have to be able to play with like real-time, you know, brightness, contrast, or exposure on these components to be able to, you know, detect what I want properly. A good option. What's wrong with leaving it for inspection for other couple of moments? So what? Chat the Oak. Who's that to? Yeah, I understand, Mitchell. Yeah. Right, except in my case, right, I get a bounds, but not every one of my boards has writing on it. Not like that, or not recognizable between revisions. And again, I want something that anyone, like the doing an image recognition on the board means that it can detect that board, save that data, and redetect it, right? Requiring people to put something specific on their silk screen on the panel at a very particular text size or very particular something else is too restrictive. No, can't use, no. Even a 50K cam won't help to snap an image. The image is going to be distorted on the sides, right? Like there's no point taking an image where, yeah. So my original prototype I did just in software was using just a single image to process, and it couldn't do the edges because they were distorted too much. So, and having a system where the camera is 4 meters away in height, really, really narrow, would require a really, really, really high res sensor, and it will introduce so much grain and other stuff. It just won't work. So I need to be close. I need to be looking at individual parts, right? I need to be able to detect that diode, right, is not sitting right. Right? And the only way I can do that is to be directly over the diode. Right? I mean, this needs tweaks, right? This is not quite in focus, as you can see. I don't care about the tops of the buttons that's out of focus. I don't even really care about the top of the IC of this chip. But this is a good example where, again, it's the wrong code path, but I can't even see the pins on the Pico D4 right now to inspect them. So, yeah, I need to be right at the part to be able to look at them. So the good news is I've got time to go through the inspection process, right? Like I need to be like, you know, one of these panels takes 15 minutes to pick and place. I've got 15 minutes to inspect the previous board. You know, an optical, like a $150,000 optical inspection machine that I can put on my line, if someone wants to lend me $150,000, they don't take one photo and then process it. Like those things sit there. Like one of my panels, it might sit there for 3 or 4 minutes, scanning and processing and checking it. I'm sure it'll do a orders of magnitude better job than what my system's going to do. But the point is, optical inspection is not. Oh, why did that die? Sorry, the chat bot just shut down. Lucky I caught it. They're not instant. They're not fast. Can we use this as a microscope? Not really what it's designed for. Why don't you just get a microscope? Or get a Raspberry Pi with a mic, you know what I mean? I'm specifically designing this, or you can do what you want with it. I'm specifically designing this to be for an optical inspection. So what I'm looking for, I don't need the level of a proper optical inspection machine. Like if I did, I wouldn't be tinkering something like this. What I need is the ability for it to go through, look at the parts, and make a calculated guess to say, this panel I think is okay, or you need to inspect this panel closer because I think there's issues with, these particular parts. Like it doesn't even have to list the parts. Right now what I do, I pick and place a whole pile of boards, of panels, and I put them next to my microscope, and I sit under the microscope doing what this is doing, looking at every part under the microscope to decide if that board is good, it goes in the pile that I pull apart, or it goes in the pile that I have to rework. That's it. I just need this thing to say, hey, I'm pretty sure this board's good. You can just pull it apart and clean it. Or I think this board has got some bad parts on it. You need to inspect it. If I can take a pile, right now it takes me about, I'm pretty fast at it, right? It takes me about 45 seconds for me to look over a panel under the microscope. I know what parts I'm looking for. I don't have to scan every single part on this panel. I know which parts are problematic parts. The diodes specifically are problematic because of the package shape and size. Sometimes they twist a little bit. I can't remember the last time I had a tombstone resistor or capacitor. It would have been 4 or 5 months ago. I don't know. Occasionally I might get a USB problem where the JLC have accidentally filled in one of the plug holes from my USB connector, and so it won't sit properly. So there might only be 4 or 5 parts per board. Hey Eric, there might only be 4 or 5 parts per board per panel that I need to really inspect that's a problematic one, right? So let's say it takes me 45 seconds to look at a panel, but I've got 50 or 60 panels sitting there, right? It's a mental thing, and you get tired or you're in a rush and you miss something, right? Because you just want to get through it all. If I could take 50 panels and turn that into 20 panels for me to inspect, that's a huge win. And so if this thing can remove, 30 panels from me having to look at that there's nothing wrong with, that's what I'm trying to aim for with this. And if it can do this on the line, that's even better. But it doesn't have to be on the line, right? I could go put a board under and walk away and let it calculate, put another board under. But ideally to do it on a line. I'm going to jump on the bandwagon for ML. Could we do some inline with ML on the parts, go through a bunch of boards and have the ML learn? Well, that's what I had working. It wasn't machine learning. I'm not sure ML is necessarily the right thing to do here. There's some problems with teaching it with ML because the range, even for me, the range of PCBs that I use, the range of part sizes that I use, the types of issues, the colors of PCBs, the thickness of boards, the whatever else, the amount of learning data it would need would be humongous. I might have to end up scanning thousands of panels to teach it. And during those scanning of thousands of panels, so the whole thing with having ML and learning is that you need a set of data, right? And that data comes from human beings, right? Like you can't teach an ML, like a machine learning system, to recognize dogs out of a whole bunch of photos until it's learnt what the dog looks like, and that happens by someone providing it here's a set of dogs, and here's a set of things that aren't dogs, or whatever. At least here's a set of dogs, right? So for me to teach this thing, I would have to have sat there already, manually taught it thousands of, this is a good resistor. Hey James, yeah, labeling or whatever it's called, right? Right, but I can do that already. So I don't have to recognize the board to do that. I could do it already, right, by having a list of here are known rectangle sizes and whatever. And so the system I did before already did something similar. It wasn't machine learning, it wasn't black box, but it did something similar where it would go. So the reason I do panel detection is because then what it can do is it can load up my pick and place file, and it knows on a panel, these are where all the parts are, and these are what the parts are, right? There's a resistor here, it's this rotation, and I know it's an 0402 resistor, so I know what its size is going to be. that is really good for teaching, because then it knows, like it could do something like recognize, hang on, why is there a capacitor there when it should be a resistor, right? Because it'll know. It knows what's supposed to be there. Now, it doesn't have to do that. It could just do bounding boxes, like shape detection, bounding boxes, and try to work it out itself. But the amount of learning data it needs from that already is massive. Like someone's got to sit there and do that. I'm not sure that that's going to be a good use of my time if I've already got the pick and place file anyway, right? And like other people wouldn't be doing this, wouldn't be needing this or doing this to check a board that they assembled if they don't have a pick and place file that they assembled it with, right? Like it's, you know, like no one's going to, like, I guess you could get a board from a CM and use it, but you still should have access to the pick and place file. Subtract one board image from the average of all board images, then you get a per board score on how different it is from the rest. Right, but I don't want to be doing it on a per board on the thing. That won't work for me because I can't always fit a whole board in there, and the camera distortion will make that not work, right? But you can see now why I need to be able to have this stepper here, why I need to be able to do compensation, but why I don't want it locked for. So one of the options I could have removed the servo by always having the head, you know, through pulleys, always be straight no matter where the arm is. The problem with that is I might find that I'm looking at this chip and there's something in the way, whatever, it doesn't matter, right? And there's something in the way, and I might want to deliberately rotate this 90 degrees to capture, right? So, and I can't do that without having the servo at the end here. I think I can do go and no go up fairly quickly because I got that working just in software. The issue is going to be getting the code to move this around and seeing how long it takes and seeing how much backlash I get. The good news is I'm not going to get any blur. The bad news is I might get some distortion on the chip, right? There's a lot of distortion there for a small amount of movement, right? So I might find that there's too much wobbliness on it. If you wanted to train a model on badly assembled stuff, couldn't you just buy $100 of the cheapest assembled boards off AliExpress and train it on that? That's funny. No, it's got to be me. It's got to take into account the pad sizes. Like look at the resistors. It can't see the resistor on there, but it can see the pad and the shape. Obviously, the lighting's not right. As I said, this lighting's set up for the other camera, but no, lens correction live won't help me because it can't show me data that isn't there, right? Like, there's no matter of lens correction and software I can do that'll re-show me the pads on the other side of that QFN. It just can't happen, right? If it's physically not there, it's physically not there. So it's going to be all about getting it in the right spot to start with. I'm not really even looking at things like the QFNs though. Like the last time I had a bad QFN soldered onto a board would have been a year and a half ago, right? Like if the solder paste process is good, catch you later, Christopher. If the solder paste process is good, then I don't have to worry about the QFNs. The things I need to worry about are, is there a resistor sitting not quite right? Is there a diode sitting not quite right? Has my little FET here, right? Is there an issue with my little FET? You know, sometimes one of the legs is sitting up just slightly. Move it above each component and capturing an image. Well, it's only near the center of the image, still be as fast as the pic. Well, I don't know. I need to see. It depends on, you know, whether I'm telling it just to check 5 or 6 key parts per board or whether I'm going to make it go through the whole thing. Until I get all this moving, right, until I got the homing right, until I get it all moving and it can actually go through, like even if I brute force it, tell it this is the board, here's the pick and place file, I need to see this moving I need to see this going, capture, you know what I mean? I need to see it doing this and seeing how quickly I can capture it all, right? What about solder bridges? I don't have any, like, again, the last time I had a solder bridge, so here's the thing. So on a QFN like this, if I really wanted to look for solder bridges, it's easy to do, right? All I need to do is, I know where the part is, I know where the center is, and I know its orientation. So I can go to here, and then I can go like this. Oops. I can go like that and capture. I can go like this and capture. I can go like this and capture, and I can go like this and capture. Right? And there, I can take 4 photos to check solder bridges if I really wanted. I actually have a board that's got a solder bridge because I had a... Oh, no, I fixed them all. Right. I had 2 boards that had solder bridges on my S3 chips from the other day because my paste wasn't warm enough yet and I was impatient. And so I pushed it hard to get the paste going and pushed it way too hard. And I got two pads were bridged just on 2 chips out of like 200 boards. It's really hard to get it to do a bridge. But I actually had, and I wish I would have not fixed them because I could have looked under here to show you. But again, it's other than those 2, and that was absolutely my fault because I was impatient. Not had a solder bridge for ages. Now, but it could be done, absolutely, right? The same way my pick and place machine can't always capture a whole IC, for instance, or, you know, like the modules, I have one anywhere, you know, like the little S3 mini modules or the S2 mini modules, right? The pick and place machine can't see that whole module in one hit. So when it goes to the camera to check it and align it, it actually goes and takes 4 photos, one of each side, and stitches it together to make a big thing. I could do this, I don't have to stitch it together, but I can do the same thing, right? I could go over here and I could look at each side of the QFN. The same with the USB connector. Like, I don't want to, like, I'm not going to be capturing the USB there. That's irrelevant to me, right? I'd be offsetting the USB. I know what rotation it is, right? I know its position, I know its rotation. I'd be capturing like this. And that's why the pick and place file approach is important, because I know exactly where it is. I know exactly the size of the USB connector, which means I could automatically have it, like it could say, oh, it's a USB connector, because it knows from the file, it knows by the name of the part, and it could automatically go and inspect the pins to make sure they're fine. Camera capture rate. Well, it's a global shutter camera. I can capture as fast as I need. This is currently set to only be, I think, 15 frames a second. What do I need? I just need I'll be able to capture way faster. I mean, this is capturing right now. 15 frames a second. If it was a rolling shutter, I'd have a problem because I'd have to get there and stop and so to make sure there's no blur and then take a photo and wait for the roll to happen. Where with a global shutter, I don't need to do that. The downside of a global shutter is it's not as high res. And nowhere near as much light comes in. Right? So you've got to play around with the light a lot. And look, I can get better global shutter cameras than this one. But this is a UVC one, so it's a USB connector. Rather than using, I can only, both of my cameras right now are USB connected ones. The Raspberry Pi's only got one camera connection, so I'd have to pick one or the other. And the problem with using, honestly, with the camera connection is the latest PiCam, or whatever it's called, stuff is missing functionality. Can you make the window of the camera output bigger, please? The window of the camera output. No, I can't. Maybe. Hang on. State. Whoops. I'm not sure how big I can make it. We'll try. As I said, it's not a high-res camera. What's that, 960? Whoa, look at that. Okay. Is there a problem with the detection of the visual pins? Do they get pixelated? Yeah, it's not great because it's not high res enough, as I said. So I've doubled, like the resolution is now 4 times the size, and look how much slower it is, right? So, but I don't need this resolution. Not in a fast way. So obviously the more pixels I'm capturing, the slower it goes. Yeah. But anyway, I've now hacked all that code. I need to fix all that stuff. So I'm just reading back to see if there's anything I missed. I don't think so. Definitely missed my cold coffee. So the plan is I need to pull some of this apart. I need to put the new thing on. I should just do that now. The camera stuff is balked. There's not really a lot I can do about that, unfortunately. This light thing's pretty cool. So I need to pull this apart. Bum, bum, bum. Okay, shall we do it? We should do it. It's not even all screwed together properly. Hey everyone, Alan says, get a thumbs up. Okay, I've only got 2 screws holding this on. So I've not even assembled it tightly because everything's temporary. Come on, get off. Why won't you come off? Oh, there's a nut still there. Okay, so good news is that can just come off. Yay. And I now need to take the stepper off. Actually, I might need to just pull this off first. So I'm not sure if you might be able to see now that that's bent. It's bent down. Too much heat. Probably need to undo the tensioners. Okay, this should just pull off, hopefully. Yay. Okay, so you can see my double bearing that I'm using. There's an inner bearing and an outer bearing. Is the outer bearing on all the way? No, it wasn't. There you go. So inner bearing and outer bearing to try to stop any lateral movement. Let's get these off. Oh, my spacers. What a thing. Hey Ian. How you doing? What a thing of beauty. Not really. I don't know about beauty, but I'm definitely going through a lot of filament as I'm tweaking the design, but that's okay. I mean, filament is relatively cheap compared to if I was CNCing stuff and wasting lots of, you know, chunks of aluminium or Delrin or whatever else. So maybe you can see that now, that it's warped down. There we go. See that? That's not really good when you're trying to get a belt going. So this new version, the USS Enterprise, has got stacks of support here to offset that. I hope it does. Okay, let's put this back together. Are you going to make the final motor mount for the bottom motor out of metal? Yeah, the idea is that once I've got a design that I'm happy with, I need to buy a CNC. I need to learn how to use. I need to buy and learn how to use a CNC, or I can get someone else to machine me parts for the time being. But yeah, the aim is to not have them 3D printed. Some of it can be 3D printed, like this whole tower can be 3D printed. Even this bit here can be 3D printed, I guess. You know, maybe the arms can. I don't know. We'll see. I mean, technically, if this was machined, I don't need these bits here. Right, I could use a much thinner piece of machine metal. Oh, wrong screw. Where's another screw? Right. But I want this to be accessible by other people. I only melted this because I was stuffing around with the homing, and I literally let the stepper. The stepper was running the whole time, like even when it was sitting there on hold. Like to get the stall guard working for homing, you need to be using quite a bit of current. Like you can't have it miss any steps, right? And so it was just sitting there hot, and as I was tweaking code, would you use a JLC CNC milling service? I don't know. I never had anything milled before, so I don't even know what file formats I need to provide or whatever else. So I don't see why not. I just don't know. I'm assuming their service would be good. I just don't know anything about it. So, okay, got to put the idlers back on. Okay, these are annoying. My tensioners. But I don't really have a choice on how they're working right now. It definitely needs to have them. Okay. Is camera pixel ratio 1:1? No, I don't think it is. So, like that's what I was seeing before, that it didn't look like it was 1:1. Okay. This is a little bit fiddly to get on, but once it's on, we're good. Just going to get over the bearings. Okay, I'll get the tensioners on after. Oh, that's off completely. Okay. So this should hopefully just press fit. Very tight, but okay. Does that look straight? I think it looks straight. Okay, so now I just need to get them in the idlers, which will be a problem. I might have to get the idlers back out again and put them back in. That's annoying. Straight-ish, yeah. So I put these side things on and now I can't get my fingers in like I used to be able to do. That's going to be...
Madsen says just make the stepper motor mount so you can adjust the tension there.
Can't with PLA. It'll move. It won't hold still. It'll melt and move. So, yeah. Unfortunately, no. Okay, I didn't think this through when I put the sides on. I now can't get my fingers in there for the tensioners. That is a problem. That is a really big problem. I can't even get the tensioner out, the pulley out. Oh no!
Alan Madsen says don't tell my car that, please.
Don't tell my PLA that. Okay. Okay, is that one of them on? Okay, I'll get it. It's just gonna be a bit fiddly. Fiddly. Thank God I've got small fingers. That's all I can say. Did that go on? Okay, I've got one on. Just need to do the other one. I don't know if I can get this second one on. Come on, get under. Maybe I'll have to tension it just with one for now. Oh, stupid fingers. Come on, get over. Oh, you're almost there. Almost. Come on. Get over. Don't recommend to try this at home. Yes, yes, yes. Okay, so I need a better way to assemble this. Oh well. Okay, I think I got it. Now can I lift it up again? I can. Okay. I got them on. Yay. That's a bit annoying though.
Quixotic Geek says designed for manufacture.
Well, it was until I put the side things on. And to be fair, I did it late last night when I shouldn't have. And so without the side support, I can get my fingers in. But now I can't get my fingers in because of these side supports. So that's what the issue is. Okay, so now I need to tension them. I mean, I've got a hole at the bottom to adjust it. So, you know, I got that bit right. Okay, so that might be a little too tight. I'm not sure that's down all the way. I have a feeling that the pulleys are sitting too high now. No, they're sitting too high. Interesting. Yeah, okay. I'm going to have to make different spaces for them. This is okay for the moment, I think. Maybe. They definitely feel like they're there's a bit too much friction on them. Okay, but that should be fine. Okay, so I think I'm going to take a quick. I saw a video a day ago where someone made a safe cracking robot who reduced the number of tries from 1 million to 152K by doing halfway between number. Oh, cool. Two image samples, half a pixel off from each other. Well, I can't move it half a pixel. Like that, yeah, so, and it's not just two images, I'd need 4 or potentially more. I'm going to do a quick toilet break, folks. So, back in a moment. If I can find where there it is. Okay, back in a moment. Okay, that was a quick 10 minutes. Um, Okay, I should put this back together. Just for now, temporarily. I will have to change those the tensioners, but for the moment, I think we're okay. Oh, you can't see what I'm doing. Sorry. I'm just screwing this base back in again. Just 2 screws just for now. And I'm going to crimp the stepper, this stepper, and get that onto the board. And my crimping stuff is, I need that, and I need 4 of these. I'm sure of that. So these are pH connectors. 2, 3, 4. Hopefully I won't wreck them. I need my crimper. Okay, and I could measure these and cut them the right length, but for now I'm just going to have them hanging out the back. So they're going to be too long. Where are my cutters? There we go. Okay, so I don't know what the pairs are on them. I wonder if they came with any docks. There might be some docks, but for the moment I'm just going to crimp them. Okay. I really don't enjoy crimping cables, connectors. Really not fun. Okay, that's one. I think it's almost time for me to take another Telfast or something. That's 2. And I'm going to mute for a second. Okay, how much did you miss? Nothing. I'm just crimping these cables, the new stepper ones, so I can plug them into my current motion controller. Oh, that wasn't good. Nope. Damn it. Did I wreck that one? I might have wrecked that one. Ah. Yeah, I don't know if that one's going to stay. Okay, I don't know if that one's going to stay. It might pull out of the connector. Doesn't the bottom stepper motor use Allen bolts to attach it? Bottom stepper, which one? This one here? They all do. They all screw in with machine screws. Hey Dodgy, it's a Scara robot that's being designed to be an optical inspection machine. It's just a proof of concept really, and may work, may not, may be good enough, may not be good enough. It's really a learning exercise for me. I never really build mechanical stuff. I'm not good at it. So the only way to get good at something is to do it and learn, which is what I've been doing. So this is as much an experiment and learning project as anything else. Okay, housing, JST 4-pin. Okay, so I've got to work out which ones are the correct ones. Is there instructions? Oh, there is. Look, it came with a card. These steppers. But does it say which wires are which? Oh, here we go. Black and green. Yeah, black and green. So, for those that aren't aware, you can determine which wires are which. Maybe not which ones are A plus and A minus, but which pairs there are. By if you see how freely the motor moves, and then if these are a pair, then when you try to move it now, it should be there's a lot of friction, which there is. Not good. My backside. It's what? What's wrong with your backside? Like if I was to take green and red together, no friction at all. So I know green and red is not a pair, right? But in this case, I mean, it's in the instructions. But, right, blue and red is a pair, and that's much harder to move. Hey, Tabletronics. So that's how you can generally tell what the pairs are. But you need to really do them in order. And I can't remember what order I did. I have to look at my KiCad. OS3. Okay, what order? Oh, wrong version of KiCad. Okay, so A1, A2, B1, B2. Okay, A1, A2, B1, B2. So black and green. Okay, and black's the bad one. Great. So black fit. Yes, black and green. and then red and blue. You know, I should have just done these as screw terminals, but they take up heaps more space. Okay, so this maybe is wired correctly. So this should feed through the side. Okay, and as you can see here, just should just plug into here. I don't know if the black one's going to stay. And I have no idea what code is on this thing still. I don't have the Pro 3 connected. I'm going to connect it now. I can't wait till I get my new controller board. Right. I do not know what code is on this thing. If I plug this in, it could go crazy. Or it could do not. Or it could complain that there's no serial and not do anything, which is possible. I need to remove that code. So it could be waiting for a USB connector, or maybe it needs a reset. Or maybe there's no code on it. I can't remember what the last data was that I did on this. Oh. Okay, not good. Okay, I think some of the last code I put on this thing was some homing code, and that would be bad. So let me just, not that one. Not that one. I'm trying to find my last set of code. Maybe this. Let me just flash it. I'm going to just unplug that for the moment. Let me reflash it. I have not failed. I've just found 10,000 ways that won't work. Yep, that's me. That's how I learn things, by finding all the ways that it doesn't work. Come on, compile. Why is it so slow? Okay. Flashy, flashy, flashy. Okay. So hopefully I can now power this up. This should just go back to that old moving code, maybe. Also might not. I don't know. Oh, there we go. Whoa. Yeah. So the stepper works, which is good. That's just that crazy code I had the other day. Just want to make sure all the axes are still working, which they are. So it's going up and down. Just want to make sure that this doesn't get too hot. No, doesn't get hot at all. Okay. It is alive, it's just not doing anything. But I'm curious to see. Hang on. Right, can't. The frame rate wise, it can't keep up with. I'll put it there. Oops, shit. Didn't mean to do that. Just want to see if it recognizes anything when it goes over that board, and it's. Oh, you can't see. Hang on. So because I increased the resolution, it dropped the frame rate badly. So let me just put that back to what it was. I'm just curious to see if it's fast enough. Oh, it's out of focus because it's moving up and down. It will move back down again. It's pretty funny. Okay, it's moving down. Yeah, so it's a bit useless as an inspection machine right now. Oh, and it doesn't get low enough, right? Because I've got no homing yet, right? So it'll. I've deliberately not made it stall for the moment, but yeah, yeah, that's funny, and it's just going to get caught on all the cables. Oh well. So it's faster. No, it's not. So the stalling you see is where it stops being able to detect stuff. It just see the red bounding boxes. Like it's finding bounding boxes pretty quickly. Then they're not right, but it's not going to be moving like this, right? Big sweeping moves. Like the movements it's going to be doing is really small. Hang on. Which one was it? So let me just take this. Okay, so okay, I'm just going to recompile. I'm going to get to do much smaller movements. I mean slower movements. This is going to slow the movement right down. I should have actually got it to do smaller movements as well. But okay. Okay, so this is slowing it. Whoa. Okay, it's not liking that. So my acceleration is too fast for the
Alan Madsen says try to pass some code in it just to move about the panel.
Oh, I can't because I don't know where it is in real world space. Yeah, I'll get rid of the Z. I'll turn off the Z. And I'll set that just to a fixed height. Just bear with me a moment. Okay, just recompiling. Alan, there is no just put some code in. Like it's rotation, it doesn't work that way. Sorry, Dodgy. So this is going to be locked still. Maybe after a reset it won't be. Yeah, okay, I know, it's stalling. Come on. So that was a stall and also a can I lower it? Oh, I need to. The EN pin is it's still where it was before. I need to fix that. So it's still locking that stepper, so I can't manually change it. Yeah, I know you understand how it works, Al. I'm saying there is no quick code. Like I don't know where any of this is in real world space. That's the whole point of the detection software. It detects a board, and then it can work out exactly where the corners are in real world space. In robot space, real world space, and then it can move around it, no problem. But I haven't got that part of the code going yet. Yes, yes. I need to change the acceleration. Sorry. Okay, I need to drop this down. So I'm telling its move speed to be faster than its max acceleration and its max speed. So its initial ramp into the move, go away, is it's not happy about its initial move. No, I can't just put some demo code in, because what are the coordinates? It'll take me an hour to work out what the demo code is. That's what I'm saying. It's not like I can say these are the positions. I don't know what the positions are. Okay. So that's moving over pretty quick. But I'll try to slow down the range of movement, not slow down, change the range of movement. Sure. But it's what I need to do is get a small amount of movement and then just orient the robot in the right direction, which is what I'll do now. But it's not going to move around the board. It's just going to swing side to side. And I need to get that not so far over. Okay. Okay. It's still... Okay, I'll keep tweaking some values. That's still too much movement. But as you can see, it's fairly sharp. I don't know if the OBS is keeping up with that. Like, because it's global shutter, it's fairly sharp. Yeah, the ML can solve everything. So I think I'm going to have a problem with how close I need to get this camera. It's got a manual focal. I can pull it higher and adjust it, but I don't get close enough to the components. Yes, this is so what I could do is this is terrible. I'm just going to add a delay. Just a quick delay to see if it holds, like to see how sharp the picture is. No, I can't move the PCB closer. It's on a conveyor. If anything, the PCB is going to be much further away than what it is right now. Don't give a knife is the right moves. The distance is actually going to be quite large, like this. I'm not going to be able to get the camera inside the conveyor to do it. So I might need to go to a different camera anyway. Oh, hear that banging? So I'm just using an Arduino delay, which is really bad. But you can almost see there's enough sharpness there. Anyway, feeling better? That's good. Yeah, that banging, I need to stop that. And it's going to slow the movement down even more, or the amount of movement. What I want it to be able to go faster. But less movement. We'll try that. Yeah, that's what I'm doing. Or not at speed. I'm slowing down how much it moves. That knocking is getting it out of position. Yeah, no. I put the unleaded in it. No, I put a delay, like with delay 100, which you can't do. That completely messes it up. But this is just crap example code. Okay, so that's too fast. I want it to be fast. I want to see how fast I can move around between different parts. But I need a much smaller movement. Like getting it to move. Why wouldn't you use overhead scanner? Overhead scanner? What do you mean a scanner? And overhead, what do you mean? Like, I'm not sure what you mean, James. I mean, there are lots of ways to skin a cat. I'm designing this with intent, right? Like I can't, like this is designed to kind of work anywhere for any purpose, to be moved but what's going to scan the board? What, get an A4 scanner and turn it upside down it's going to interfere with the thing. And how's that going to work? And yeah. This is just an early prototype of a Ascara robot. Yeah, okay. I'll slow it right down. Ascara robot that... Got to remember, what I want to do is go to a position, hold for a little bit, go to position, hold. I want to be able to move between positions really quickly. So moving it slow just to show you what it looks like is fine, but that's... The intent is to have it move around really quick to each part, stop to take the photo, and then move on again. I don't expect to be able to see what it's doing in a preview screen like this. It'll be way too fast, if that makes sense. That's the whole point of using a global shutter. So, sorry, to go back to your question, Andy. So it's a prototype of a Ascara style robot that has two cameras on it, top one here for board detection and identification, and then down here a lower one that does inspection of parts. So it's you can sit it on a conveyor. See, that's slowed down, but again, the whole point is I probably need to up the stepping, the micro stepping on it. It's only on 16. Let's go 64. That's right. So it'll detect a board, work out where it is in space. I've already got that working. And then it identifies what the board is, and then so it knows where all the parts are, and then it goes and keep high speed, but add. I've already got that, but I don't want to be easing in and out of every movement like that. Not too much, because I don't want to waste that time easing in and out. Right? Again, global shutter camera, I don't need to. Like, it's not going to blur. I just need to get there and take a photo. Yeah, I mean, I'm not sure what this is showing in terms of a proof of concept, because it's not. This is not really indicative of what it's going to be doing. So I don't know if that's more jerky or less jerky. Hey Iggy, how you doing? Better late than never, yeah. So there is ease in and ease out on this, but again, I want to keep it to a minimum. Like, there's no way that as I mentioned earlier, for those that missed it, right now you're looking at camera output from a Raspberry Pi via VNC, via Wi-Fi, that's then being captured on OBS. So there is a massive amount of lag in this that is purely Wi-Fi VNC, right? It's because it's updating. The whole window is a VNC session, so it's not like I'm looking at the actual video output, right? So this is already compressed and delayed and laggy that I'm then capturing and showing you. I also see that lag in VNC here, right? If I had a HDMI monitor plugged into this thing, to the Raspberry Pi on my desk, what I'd be seeing would be updating on the screen way faster than this is, right? Like a lot of the blurriness in that image moving is because of the VNC compression. Only at the approach to destination slowly marginally reduce error. Right, but I don't need the precision I'm looking for is not that yeah. I don't need to hit the component, 20 microns of its actual position to mount my 10 megapixel Raspberry Pi scope cam, just because it's neat. I've got that. Whoop. Iggy. I've got. The problem is it's too heavy to throw around. It's just way too heavy. Way too heavy to throw around. Although I've unplugged it at the moment, and that's the new Raspberry Pi 3 camera, which I might end up swapping out this top camera for the 3, this one. Yeah, I got the same setup here. It's pretty good, but it's way too heavy to move around. I mean, this weighs more than like this whole arm with a stepper. The lens is really heavy. So, yeah. And you need a lot of light around it. So, like when it's zoomed in, you need a huge amount of light. But yeah, I thought of that originally. But you don't need an excuse to build one. Although you might want to wait till I got the design refined a bit more. I wonder how long my print's got to go. Oh, excellent. I've lost my... Oh, there it is. It's a bamboo. Oh, 36 minutes to go. So they're the new parts being printed at the moment on the bamboo, which is just such an awesome printer, I gotta say. I'm very impressed with it, with its speed and reliability. I mean, it's moving so fast that it can't even keep up with the picture. So 36 minutes to go. But I don't know if I'm going to pull the robot apart to get that on the stream now, because it's that's the whole thing's going to be pulled apart to get the new arm section in. If I drop that down. Yeah. So like until I can, so the next step for me is rebuild the arm, and then I need to go back and, as you saw, I've got the size close now on the detection stuff. I might actually put that back. So what I need to do is get it to go, I need to get the limits working, right? Oh, is that paper gone? I need to work out lighting. I need to get the limits working. Get my hand out the way. Why is it not detecting? So it's, see, that's interesting. That's not quite recognizing it the same again as it was last time. But whatever, grab that, whether it works out what the board is or not. From that there, I can work out where these four corners are, right? And then I have to just work out, I need to implement some basic IK to get it to move around the outside of the corners would be really good. As a proof of concept, but I need to, all that has to happen in C on the microcontroller with, I need to put together a serial interface so the Raspberry Pi can tell the microcontroller what to do. Yeah, the heavy cam mounted high enough, you might only need to tilt it, just having to move it. You can't tilt it. You can't tilt the camera. It's got to be moved. As soon as you tilt the camera even 0.1 of a degree, everything's distorted. You can't. It's got to be completely straight down. That is not straight. That's the other problem. Is this camera here is, I haven't got a way to straighten it yet. It's on a rotation thing, so I probably want to. Why is it not recognizing the board size? No, it can't. So I originally had a gantry. It can't be Core Y. It can't be. So there's no place for it to sit over a conveyor to be a Core Y, a Core X, and it can't be a Core XY because it gets in the way of things. It needs to be Core XY is where everything stays on top, and like a level, the base moves up and down. It's not what I want for this thing. I think that I personally think the Scara is the best option for this. It sits to the side, it sits out of the way, it doesn't have to sit over, it doesn't require any particular type of thing for it to sit on, and it'll do everything I need. Like a gantry is not the way to go. That's how I originally started, and too problematic. If the board's too big, if the board's too small, right? It's just throwing around heaps more weight. Can't easily be manufactured. Where this thing, I mean, as I said, it's all 3D printed right now. So I don't know why that's not detecting. This is also sitting probably way higher than it needs to be, right? I mean, my original idea was to have it lower, but the arm was in the way. But now that it's not in the way, Like, you know, the PCB could be here. Well, maybe not there, but, you know, it just needs to be able to grab the largest board. Let me just grab my biggest panel I've got. I'll show you. Just going downstairs to grab a Reflow Master Pro panel, which is probably my largest at the moment. I'm not expecting this thing to be able to capture, you know, a 300 by 300 millimeter PCB. I mean, I don't have anything that big, and this is probably not the type of thing you want to use if you do. Okay, let's move back up. Okay. This might not be the biggest panel I've got. I think maybe some of my prototype boards are bigger, but sorry, I got cables all in the way. Right, so that's having trouble grabbing that because of the lighting, because it's red, right? So, hey, Life in Cycling. So this shouldn't be capturing in color, but I haven't done that yet. This should be taking the image and converting it to grayscale and then only using saturation to do it. Because that'll get rid of all the lighting. So that highlight down here, because of my overhead lights, like if I was to go like this to block out the overhead light, some of it. See, that's the other problem with the gantry. Sitting over the top is going to cast shadow on everything, which I don't want. There we go. So that's grabbing the board. So it needs to be this high to be able to grab that. And it's grabbing it close enough. Maybe, we'll see. A lot of opportunity to tune that. Whoop. So that's another thing. Lighting is a problem, right? And interference lighting from other things. So could you imagine if there was a gantry sitting over the conveyor and then light from the side would hit the extrusion, which would cast a shadow on the board, which would cause a problem. Stuff like that. Yeah. Okay. So I've just left this in the state where the steppers are just sitting there getting hot because they're currently running, because this code is running, which I should probably... Whoa! Didn't want... Shouldn't have done that. Whoops. Sorry. Yeah. So they were just sitting there holding, right? That's the other thing I need to do. Like the code, it shouldn't just sit there holding the steppers when it doesn't need to. So the only thing that needs to be engaged when it's sitting there idle waiting is like, so this stepper, so that stepper should be off. Servo doesn't matter. That'll be off. And this doesn't have to have hold on it. This one here, it just needs to get to its inspection position, right? And it can disable itself. It doesn't matter if it's got the ability to move, because there should be nothing moving it. And it doesn't matter if it moves a bit, right? Because it can still capture, like even if it's at an angle, right, it can still capture, as long as it's not sitting there vibrating, which it won't be. So, like I just let them sit there for a while, and you know, these are quite warm. But I'm also probably running too much current in them. I don't need that much current. Right, this one's been off, right, because I manually adjusted the height, and that's got no heat at all. All maker YouTubes know PCBs defy regular optical rules and will always reflect a light source directly toward nearby cameras. Exactly, it's like a campfire. No matter where you sit, the smoke always goes in your face, right? It's just the rule. If you're going to sit at a campfire, smoke in the face. Yeah, so I don't want to restrict anyone's PCB. Look, I don't know if this is ever going to work. I don't know if it's ever going to be actually useful to me or not. I don't know. I have no expectations that this is going to be a great solution. It might not be. And even if it's not, once I get the design kind of, I'm happy with it, I'll release all the files. You can all, although straight up, there will not be any Fusion 360 files of this because my Fusion 360 project is indecipherable. Sorry, forget it. Forget it. But I will release step files of them all so you can modify it. All the different parts. I'll release the design for my controller board and whatever bits of code I get working, whatever. And if anyone wants to make something and tinker with it, they can. Right? I'm not looking at making a product out of this. I'm not looking at or anything like that. And I don't know if it's going to be useful or not. And it might be useful for other things, not inspection related. I don't know. But as I said, it's a learning project for me. And if I get something out of it that helps me in any way, that's a bonus. You know, and if it helps anyone else, that's an even better bonus. But there's a long way to go still. There's a long way to go. But now that I've got the cameras working-ish, yeah, until I get the new controller board, I'm not going to be able to control it properly. But once I got the new controller board, I can turn the lights on and off as I need to. I can control the servo. I can obviously control the steppers. I can, and I'll be able to interface with the Pi properly. And once that's done, I'll be able to mount the Pi at the back. That's the other thing. The Pi gets quite warm, like quite warm. There's a Raspberry Pi sitting here. Like if I put that in here, it's gonna, like, even though there's standoffs, it's gonna melt the inside. So I'm gonna need a fan in there. Oh, that's what I didn't do. Is I didn't put a fan header on. I could put one. I could use the Pi, like a 5-volt fan in there to cool it in the inside, which means I probably need some air vents on the back of the case. So, excuse me. There's a few things to do. I bought new linear rails. I got them from AliExpress though. They haven't shipped yet, which is really frustrating. So 200mm ones. But I still think I'm going to have a problem where I'm not going to be able to get low enough from here. I don't know. But my next step is to get the controller board in, the new controller board in, to have it. In the meantime, I can play with capturing a board, corners, and then doing the inverse kinematics to work out the maths to get this camera into the right spot. I want to be able to go like this. Move along here, go like this, move along here, and go like this. There's also a problem with this build, which is being fixed right now, is I got the screws too close, and so that's why it was locking before. Oh, interesting. I didn't tighten that. So it's getting stuck on the screw, and it won't go far enough. It needs to be able to go much further back. So that's been fixed. These screws have been pushed all the way over so it can get further around, because right now it can't get to the corner. Right? It needs to be able to, if I just undo this a bit, it needs to be able to come in to there. See that? To get to the corner. Oops, didn't mean to move that. And so it needs to be able to go in far enough that it can travel along this edge. And it could be that it's too far out. Like maybe I need to, you know, maybe there, I have to work out where it's going to sit. And where it captures from. See, that's not in the center now. And if that's in the center, so I might still need this to go out further, because to get this in the center, for instance, I don't think the arm is going to be able to follow along the front. Oh, maybe. No, probably not. Probably not. So, but if I can get it moving around the corners like this, that would be, that's my next step, is to do that. Should be lots and lots of good IK code. Oh yeah, there's stacks. Yeah, James's stuff is awesome. There's, I found heaps of reference, and it shouldn't be too problematic to get that working. The question is going to be like where I'm going to do most of the computation. It would make more sense to do it on the part. No, all the IK will be solved in C, like on the Pro S3, but it would make sense to do all the rest of the stuff on the Pi in Python, and then just say go to this position, send it to the position to the Pro S3, and it then does its IK calculation to move it. What about make the moving arm a C shape to be able to reach around the robot body? But no, yeah, no, because sometimes it needs to go this way, right? It's yeah, you don't know. It's all rotation. Well, as soon as you do an offset like that, it breaks all the maths. No, it's fine. I need to be able to. It's just a range thing. Like I've not had all this kind of in the right spot yet to work all this out. Like this probably only needs to move out. Like this is almost there. So this is about, let's call it 10 millimeters, yeah? So this only needs to move out maybe 5 millimeters. Right, to fix this 10. I mean, we're talking about a small amount. Yeah, I don't think it's a... And that's my widest panel, right? The same thing here. Okay, this can easily move around. See that? No problem. So it's a really small amount I need to adjust it to do that. Very small amount. Yeah. It's the only problem with that design. The arm movement path is far more complex than a gantry. No, it's not actually. It's easier than a gantry. Way easier than a gantry. That's what inverse kinematics is for. So the maths is already out there. So unlike a gantry where you say, I want to be over here and it's got to work out, well, it's just maths, right? It works out the position on the X and the position on the Y, whatever. This is the same. It does it with rotation. It's no harder. It's just an algorithm, right? So yeah, this has been solved like decades ago, like 30 years ago, 40 years ago. This has been solved. Yeah, I'm not worried about that. But I definitely think I'm going to potentially have to change cameras, go to a different camera. But we'll work that out. Okay, so I have to turn the pick and place on, and I need to assemble stuff. Where's my other stepper? Oh, put it back. I really need to, I want to keep tinkering, but I'm not going to be able to today. Maybe later, I will. Once these parts are printed, I'll get them swapped over maybe later on this afternoon, if I have time. But yeah, it makes more sense to have just to bring this out another 20 centimeters. That's what 20 millimeters, right, or whatever. Bring it out. The further I bring this out, the further away I can be, so long as the arm can still reach, right? So I need to put, no, you can't see that now, sorry. So I need to put like if here's my conveyor, I need to put this at the edge of the PCB, so like right there, right? The furthest edge of the widest PCB I've got, and then I need to go back and go, where is this in terms of the center, right? And shift it so it's in the center. Although my conveyor doesn't center the boards, the conveyor is fixed on one side. So that's an interesting problem. So my center point might have to move back and forwards. I don't have to be in the center of the board to capture it, right? Like that's not quite in the center, right? If I put it over here, I know why that's failing. I've got a center check thing. It's close. Can reach and adjust the top camera extension. What? Calculate, test, see how long the rotating arm can reach and adjust the top camera extension by that amount. Well, Alan, you're free to do an X, Y, and a Z version, but I think it's the wrong design. Definitely not something I'm interested in. I've already built one. I think that it's way less versatile than what I'm doing. So, but you're free to build one. No problem. So if I just go to detect panel. So I have a thing that checks if it's close to the center or not. And that's why it's coming up with, right, I think it's here, the width quarter. Yeah. And that's why it's not letting me do it. So if I make these, I think I make them smaller, maybe. Catch you later, Dodgy. Detect movement. Okay, there you go. Almost. Right, so it's capturing. So as you can see, it doesn't have to be in the center to capture it. The question is, can it capture it reliably at the right size? Keeps jumping around a bit. So long as it can capture the right size, I think that's just a lighting issue. Oh, now it's out of focus. Great. That's the other reason I might have to switch cameras, is I might have to go to one where I can lock the focal point. So that's close. So the point is, it doesn't have to be directly over the top. It just needs to be within a particular range. So I don't think the always needing to be in the center is going to be a problem. And you can move if it turns out to be too long now and reprint, optimize later. Yeah, for sure. Possibly wagon loads, but I don't know. That's how that's all going to work yet doesn't really matter. Right now, I want this working on a desk, right? Right now, this can't interface with none of my conveyors can be interfaced with to say stop moving. I'm going to have to hack my conveyors to be able to do that. Excuse me, hack them as in solder wires in and do stuff, or completely replace the controller for this to be able to communicate with the conveyor, and when the board comes in, for it to go, oh, I've seen a board, movement detection, stop the conveyor, right? None of that is possible right now. So I need to solve that still, but there's no point solving that if I haven't solved this, right? If I can get this to detect that board, go find it in real world space, and scan it and get some decent images from it, then there's no point doing the other stuff. The protocol's easy, but I can't interface into the protocol. The protocol can't stop the conveyor mid-run. The protocol is just does a send me another board. So is there a board to come in, and is there a free spot to go out? And that stops the board at the end of the conveyor before it goes through. You can't just say stop the motor. That doesn't work with these, right? So I can't interface with the hacked SMEMA process of that. Going to add a proxy. What do you mean what? Proxy to the steppers. I don't know what I'm going to do. As I said, I don't know what I'm going to do, because whatever solution I come up with has to be repeatable by other people. So I don't know yet. That's for future Sion to worry about. I just realised that whole time you couldn't see what I was capturing on the screen. I was just showing before that I can. It doesn't have to be in the centre for it to capture now. So it does have to be on a particular angle. As you see, it'll discard it. It'll only go from 4 and -4. And I did that on purpose because it does a correction on it when it captures. Some middleware, some hacking of the hacking. Yeah. Okay, almost 3 hours. I think I should go power up my production line. So, there we go. I was hoping to be a lot further along than this week, but as I said, I've had lots of other things that were more important. I'll just keep chipping away. This is living permanently on my desk, although this desk is sitting over here normally when I'm working because it's in the way. And it's on. I can code on it, hack on it whenever I need to, a bit at a time, whenever I have time, and hopefully, bit by bit, I'll get there. Thanks, Iggy. You too, mate. Hope all is well on your side of the Murray. Are you on the other side of the Murray? I think you are. Yeah. Oh, well. Does the conveyor have a jam detection sensor so you can... No, it doesn't. It's got no ability to do anything like that. There's an in point and an out point, and with sensors there, and that's all it can do. It's got no other ability at all. So it needs something very custom to do that. Thanks, AJ. Me too. I'm overdue for some more Telfast, and Panadol. Thanks, Peter. I'm keen to see whether your camera will give me... I think your little micro camera will allow me to lift higher, but I'm just worried about how much distortion it'll be and the fact that it's a rolling shutter, not a global. So I might have to look at some other global shutter cameras, or see if I can find one that's got a better lens, like a narrower lens, so I can get it further away. But we'll see. Oh, Photochromax, you were late, just in time for me to end the stream. No, definitely lots of coffee, though cold coffee. I survive on coffee. Okay, almost 10 o'clock. I really need to get some work done. Bye, everyone. Thanks very much for joining. Thanks for your thoughts and insights. Alan, I look forward to seeing your XY version of this. Will you have it ready for next week? Yeah, no. Everyone is free to design something better than this if they want to. This is just my path I've chosen. Didn't say it's the best path, just my path. Okay, that's it, folks. I'll catch you all next week. Have a fantastic week. Bye.